Hey, what's up, guys? So, actually, before going to bed, I'd like to briefly talk about this like interesting problem, number 1041, robot bounded in circle. Um, it's an interesting problem. I mean, let's take a look. So, on an infinite plane, okay, a robot initially stands at position 0 and 0 and facing north. North means up, okay? And the robot can receive one of the three instructions. Basically, at each step, the robot can do one of these three actions. G means going straight. Going straight, means like followed the current direction and going straight by 1 unit. Left means turn left by 90 degree. R means turn right by 90 degree. Okay, and it asks you to return true and if and only if there exists a circle in the plane such that the robot never leaves the circle. Okay, so what does this mean? It means that it given like this kind of like instructions, right? I mean, it asks you to check if the basically if the trajectory of the robot is within like a bounded circle or like a bounded range. Okay, so which means I mean, for example, this one. Okay, so the G means right going. So we have okay. You know what? Actually, so this one means like going up by one and then going up by one. Okay, and then next turn left. Turn left here is going reaching turn left and then turn left. Basically turn around. Okay, and then they do another like move here. So going here and then come back here. So after this like string of the sequence of instructions, the robot came back to the to where it started. Okay, that's why I mean the output is true. Okay, and another example here is like this. Okay, this is like pretty obvious, right? I mean, since the robot can only going up and up. Okay, so it basically will just keep going up indefinitely. Okay, and another thing is that I mean this is like example three here, right? So going up and then it turn left. Okay, basically, so for this case, right, after like three re, three repeats of these instructions, the the robot will come back to the original state here, right? Because here, it goes here and then turn left again, and then turn left again, and then it will come back to the original to the starting point. Yeah. So I mean, basically, I think for this, the key thing for this problem is that you just have to be able to figure out there are like only two cases that we can check that can tell us if the robot's trajectory is within a bounded circle. So the first one I think is pretty obvious, right? Because I mean, basically after the af by the end of this action of strings here, if the robot came back to the original to 0, 0, and then we know that, okay, it certainly will the trajectory is within a bounded like circle, right? And the second one is that I mean by the end of this string, the actions here, if the robot is not facing north, okay, then any position, any direction is okay as long as it's not facing north. Then we can prove that, I mean, by at most four repeats of this command here, the robot or the instructions here, the robot will will be able to return to the zero to the zero to the original starting point. I think it's not that hard to come up with, right? Basically, I mean, it doesn't really matter. I think as you can do this like this. It doesn't really matter. I mean, as long as the last one is not like going straight up, right? Because it kind of makes sense, right? Because if the last by so if the last direction is still facing up and it's not on in the original positions, I mean, from from the next one, it will basically keep going up, 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 and it will never end. But if the last direction is facing like on the other direction, okay. For example, if this facing left, okay, if this facing left, and then the basically you can rotate, right? Basically, after the second repeats, basically this whole part will be rotate like a 90 degree. So by the end, the whole path here will be like somewhere here, okay? Will be here, 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 and in the end, this thing, in the end, like the the direction will facing down, and the same thing here, and the next one it will facing right, basically. So it's not. I think there's a proof that as long as the last direction is not facing north, which is the same direction as the starting point, then after at most four repeats of the instructions, the robots will definitely come back to the original place. Okay, so with that being said, I think now it's clear that uh, we just need to go through the instructions. And while going through the instructions, we just need to maintain two things. First thing is that the current location, right? And second one is the current direction. Okay, cool. So let's start coding here. Um, you know, since we have either turn left or turn right, I mean, we have to use a small trick here. Basically, I mean, I'm going to define like north means 0, okay, and east means 1, south means 2, and west means 3. Basically, I'm doing like a counterclockwise here. So at any given any directions here, we can come up with the either left or right. Okay, since I'm defining this thing like a clockwise, so which means the let's say the current direction is I is like in the 0 to 3 here. Okay, so at the current direction I here, if we're turning to right, then we simply do a +1, okay, and then we do a mod by 4. Okay, that's pretty straightforward, right? This is for right. How about the left? Left means like we actually need to going back by 90 degree. But how can we know if it's going back or not? Okay, basically we can just do a like another. We can just go over like uh, going to this direction. Let's say if we're at here to here, we need to go to 1 here, right? But instead of minus 1, okay, because if we do I minus 1, I mean if we're at 0, I mean 0 minus 1 will be like what? Minus 1, right? So instead of minus 1, we can do this. We can do a I plus 3 mod by 4. This is going to be left. Okay, basically this is like I minus 1 plus 4, right? And then mod by 4 so that we can make sure the value is always like a positive number. No, sorry, non-negative number. Okay, cool. So that's basically the two things here. And since we have defined the directions here, I mean, and when we define the directions list here, we have to follow the same order. We cannot just do a random order here because, you know, since we also need to maintain like the current position, right? That's why I mean we have 4 directions, right? So the first one is 0, 0 means going up. So what does going up mean? Going up means the x will be -1, okay, and the y will be 0. That's going up, okay. How about the second one is going to the right side. So going right side means like 0 and 1, okay. And then the next one is going down. Down means like 1 and 0, okay, right. And then the last one is going to the left. Left means 0 and -1, okay. Okay, and now I'm going to define like current directions equals to 0 because at the beginning I'm defining 0 as the north, okay, and then the current location, right, is 0 and 0. Current position is 0 and 0. So now I just need to simply loop through the instructions here, okay. Uh, okay, if the instruction is equal to the G, okay, so G means what? G means we just follow the current direction, and then we just move move the by 1 unit. Okay. So the current direction, the x is what? X is the current p dot 0. Okay. Y is the current p dot 1. Okay. How about the direction? The direction is directions dot current direction. Okay. Then the new x is what? Is x plus the d0, okay? And the new y is the y plus d1, okay? So, and yeah, and then we just update the current position, okay, equals to this, right? New x and new y, okay? Else if the instruction is left, okay, then we simply do this. The current direction equals to what? The current direction plus 3 mod by 4, okay? Else if the last one is right, okay, so current direction plus 1 mod by 4, okay? And in the end, like I said, we simply check, right? We check two things. Check if the current direction is not facing north, or the current position is 0, 0, okay? Either of these two is satisfied, then we know this the robot is bounded. Okay, run it. Oh, yeah. So this one test case passed. Let's try to submit it. Cool. Yeah, so it's accepted. I mean, it's not a hard one, but it's a very interesting one. I mean, right? I mean, it's just you just need to notice that there are like only two cases, okay, to be able to make this robot bounded within like a, a finite uh circle. Yeah, I think that's it. I think we don't have to worry discuss about any of the space complexity or those kind of stuff. It's pretty straightforward. It's all of n. And cool. I think that's it for this problem. Yeah, thank you so much for watching the video, guys. Stay tuned. See you guys soon. Good night. Bye bye.